Okay, before we actually starting of ECN subject, we have to know some basic things. So in a few lectures, we are going to see some prerequisites we should know. Okay, so that we can understand the ECN subject very well. So let us see with some basic concepts regarding electrical circuits and networks. So first is DC quantity. So the quantity may be voltage, current or power. Okay, so electrical quantity, there are three types of basic electrical quantities, which is the voltage quantity, current quantity or a power quantity. So let us see what is the DC quantity. So it is the electrical quantity which may be voltage, current and power, which does not change its magnitude and phase with respect to the time. So if you see, there are two diagrams. On right hand side, yellow line indicates the DC quantity. So what is DC quantity? DC quantity is the electrical quantity which may be voltage, current and power, which does not change its magnitude and phase with respect to time. So on x-axis there is a time, and on a y-axis there is a voltage. So voltage is constant throughout the time. So voltage is not varying with respect to the time. Voltage is constant. So DC, in the DC quantity, voltage and its phase. Voltage is nothing but the magnitude, and phase is nothing but the polarity. So the voltage polarity is completely positive throughout the time. So that's why it is called as the DC quantity. So DC quantity is the quantity, it does not changes its magnitude and its phase with respect to time. So magnitude and phase with respect to time is constant. That's why it is called as the DC quantity. Okay, so on right hand side there is a diagram which indicates the DC quantity. So DC quantity having a constant magnitude with respect to the time. Next one is the AC quantity. So it is the electrical quantity which may be voltage, current or a power, which changes its magnitude and phase with respect to the time. So first diagram, on a left hand side there is a AC quantity. So in the AC quantity we can say that there is a change in magnitude with respect to the time. So on x-axis there is a time, and on a y-axis there is a voltage or a magnitude. So in AC quantity, with the observation, we can say that in AC quantity the magnitude is changing with respect to time. As time changes, magnitude also changes. Also its polarity is also changes. So for some time its polarity is positive, after some time its polarity becomes negative, after some time its polarity becomes again positive, again negative. Okay, on above x-axis there is a positive polarity, and on below x-axis there is a negative polarity. X-axis is nothing but the horizontal line. Okay, so in AC quantity is the quantity which changes its magnitude and its polarity with respect to the time. That quantity is called as the AC quantity, and that AC quantity may be voltage, current or a power. So in a AC quantity is indicated or given in a red line. Okay, and its magnitude is not constant throughout the time. But in a DC quantity which is given by the yellow line, whose magnitude is constant with respect to the time, so which is called as the DC quantity. So what is the difference between AC quantity and DC quantity? In AC quantity magnitude changes with respect to time, and in DC quantity magnitude is constant throughout the time. In AC quantity polarity changes with respect to time, but in DC quantity there is no change in polarity. Polarity is constant throughout the time. Okay, that is the AC and DC quantity. Next one is the waveform. So waveform there are different types of waveforms given here. Okay, one is the pulsating waveform given in a blue color. One is the direct waveform or a DC waveform. One is the variable. Okay, and another one is the alternating waveform. Okay, so what is basically waveform? Waveform is the graph. Which kind of graph? Magnitude of quantity with respect to the time. So basically waveform is the graph of magnitude of quantity with respect to time. If we plot the graph, okay, if you plot the graph of magnitude of any quantity with respect to time, it becomes the waveform. So we can represent the alternating quantities with different ways. One simplest way is to with the help of waveform, and another way is to way with the help of mathematical equation. So for better understanding, we can use the waveforms. Okay. So waveform is nothing but the graph of magnitude of alternating quantity or any quantity with respect to the time. With respect to time, if you plot the graph of magnitude of any quantity, it becomes the waveform. So there are different types of waveforms. In the red line, it is the sinusoidal waveform. Okay, sine is nothing but the sinusoidal. In the green, it is the square waveform. It looks like the square. In the blue line, it is the triangular waveform. It looks like the triangle. And last one, in the pink line, it is the sawtooth waveform. Okay, it looks like the tooth of the hacksaw. Okay, so according to shapes of these waveforms, names are assigned. Okay, so first one is the sinusoidal, next one is the square wave, third one is the triangular wave, and last one is the sawtooth wave. So these names are assigned according to the shape of those waveforms. Next one is the instantaneous value. So what is basically instantaneous value? Instantaneous value of AC quantity is defined as the value of that quantity at particular instant of time. If you find the value of that quantity at any instant of time, that value is called as the instantaneous value. So if you see in the picture, or if you see in the diagram, there is a sinusoidal waveform. On x-axis there is a time, okay, and that time begins from 0, and there are different time instant 1, time instant 2, time instant 3 up to time instant n, and each time instant has a corresponding value of AC quantity, which is the I1, I2, I3 and In. So the value of I1 for the time instant of 1 is called as the instantaneous value for a particular instant of time, which is the 1. Also I2 is nothing but the instantaneous value of AC quantity for the time instant 2. Also I3 is the instantaneous value of AC quantity for time instant 3 up to n. So In is the instantaneous value for the time instant n. So what is that instantaneous value means? Instantaneous value means it is the value of that quantity at any given instant of time. Okay, if you measure the value of that quantity for a particular instant of time, that given value is the instantaneous value, and that instantaneous value changes with respect to the time. At time instant 1 it gives us I1, at time instant 2 it gives us I2, okay, and at time instant n it gives us the In. So instantaneous value is the changing value with respect to the time of AC quantity. Next one is the cycle. So what is cycle? Each repetition consisting one positive and one identical negative part of waveform is called as the cycle. So there is a repetition. What kind of repetition? One positive and one identical negative part of waveform. So given diagram is the waveform. Already we have studied what is waveform. Waveform is the graph of magnitude of AC quantity with respect to time. Okay, so it is the graph. What kind of graph? Magnitude of quantity with respect to the time. So what is cycle? Repetition of positive and identical negative part. So one cycle is indicated here on the top of waveform. One cycle consists of positive part and one identical negative part. That whole part is called as the one cycle. And one cycle consists of 360 degrees or a 2 pi radian. In a degree it is of 360 degree, and in radian it is of 2 pi radian. So what is cycle? It is the combination of positive part and identical negative part. That combination is called as the cycle, or it is also called as the one wave cycle. Next one is the time period or a periodic time, and notation is T. Time period is defined as a time taken by waveform in seconds to complete one cycle. So to complete one cycle, that sinusoidal quantity needs some time. That time required to complete one cycle is called as the time period. So one cycle consists of positive half part and negative half part. So to complete this positive half and negative half, it needs some time. So that time required to complete this positive half and negative half, that is one complete cycle, which is called as the time period. So it is simple statement. Time period is defined as the time taken by waveform to complete the one cycle, and that time should be in a seconds. Okay. Then frequency. So what is frequency? It is defined as number of cycles completed by alternating quantity in a 1 second. So in a 1 second it can complete the multiple cycles. So how many cycles it can complete in a 1 second represents the frequency. So in a 1 second it can complete 2 cycles, 3 cycles. So if it complete the 2 cycles in a seconds, then it is called as the 2 hertz of frequency. If it completes the 50 cycles in a seconds, then it is called as the 50 hertz frequency. So line frequency which we receive at home from the MACB, which is the 50 hertz. So that signal or that AC quantity can complete the 50 cycles in a 1 seconds, and unit of frequency is the hertz. So what is basically frequency? Frequency is nothing but the number of cycles completed in a second. How many cycles that AC quantity can complete in a 1 second, that number gives us the frequency, and line frequency is the 50 hertz, 50 cycles completed in a 1 second. And what is the formula for frequency? Frequency is equal to 1 by T. T means time period. Already we have seen the time period. Time period is the time required to complete the one cycle. If we take reciprocal of it, it gives us the frequency of the sinusoidal waveform. So high frequency and low frequency. In high frequency there are number of cycles completed in a 1 second, and in a low frequency there are less number of cycles can be completed in a 1 second. Next one is the amplitude. The maximum value or a peak value of AC quantity is called as the amplitude. If you see the maximum value from the reference, so on x-axis, okay, there is a horizontal axis which is the reference axis. Above of it there are the positive values, means positive voltage, and below of it there is a negative value or negative voltage. So if you measure the magnitude from reference axis to its positive peak, or reference axis to its negative peak, which gives us the amplitude. So the maximum value or peak value of AC quantity is called as the amplitude. And how to measure the amplitude? Measure in between its reference axis and the peak node. So that measurement gives us the amplitude. And peak voltage is denoted by Vm, and peak current is denoted by Im. If it is the waveform of voltage, then peak voltage can be represented by Vm, and if it is the waveform of Im, or if it is waveform of current, then the notation for peak current is the Im. So what is basically amplitude? Amplitude is the magnitude, or amplitude is the measurement between reference axis with respect to the peak node, positive peak node, or the measurement between reference axis bit and negative peak. Okay, that magnitude is nothing but the amplitude. Then angular velocity omega, it is not W, it is the omega. So angular velocity of alternating quantity is the rate of change of angle in radian with respect to time. How much angle that wave can complete in a 1 second. Okay, that angle in radian is called as the angular velocity. What is angular velocity? Angular velocity of alternating quantity is the rate of change of angle in radian with respect to time. What is the rate of change of angle in radian with respect to time? That rate of change of angle with respect to time is called as the angular velocity omega. Also in simple terms we can call it as angle covered by AC quantity in 1 second. How much angle covered by AC quantity in 1 second, that amount of angle covered is called as the angular velocity. And formula for angular velocity omega is equal to 2 pi f. Why 2 pi f? One cycle constitute of 2 pi, and the frequency is nothing but the number of cycles completed in 1 second. So if the assume that the frequency is 50 hertz, so 50 into 2 pi gives us the angular velocity for the 50 hertz waveform. So angular velocity omega is equal to the 2 pi f. 2 pi is the one cycle angle, that is the 360 degree or a 2 pi radian, and f is the number of frequency number of cycles completed. Okay, so whole cycle angle, one cycle angle into number of cycles gives us the angular velocity. Angle covered by that waveform in a 1 second gives us the angular velocity. Then peak to peak voltage, and notation is VPP. Peak to peak voltage is the voltage measured from maximum positive level to maximum negative level. So if you see in the diagram, so peak to peak voltage is the voltage measured between maximum peak to negative peak, or positive peak level to the negative peak level. So, or it is the in between positive peak node to the negative peak node. So that voltage is gives us the peak to peak voltage. Okay, and notation is VPP, and value is Vm minus minus of Vm, which is equal to twice of Vm. So Vm is nothing but the amplitude. Amplitude is the voltage measured between reference axis to its positive node or positive maximum value, or reference axis to the its maximum negative value, and it is the twice of amplitude. So peak to peak voltage is always the twice of its amplitude. Are you getting what is peak to peak voltage? Peak to peak voltage is the voltage measured between maximum positive level to the maximum negative level, and which is shown graphically. So with this we are going to stop here.